is the basis for the multiverse. That's plenty of universes, you know? I think E. Cummings said there's a hell of a universe next door. Let's go. Well, there's a lot of universes next door, except we can't really reach them. So quantum fluctuations and string theory provide this context for the idea that our universe was not a unique event. And how can we test that? Of course, that's the current question on the plate of cosmologists. Is this a testable idea? String theory is difficult enough to test, let alone the idea of a multiverse. So I won't pretend that it has been tested, and I won't even pretend that it can be. It's a frontier idea that we hope, maybe in a decade or so, to be able to test. And so in this inflationary model, different space-times spawn with different laws of physics, and the idea is that our universe is quite special because it was long-lived, and it formed stars, and the stars made carbon, and the carbon sat around long enough at an equable temperature to make biology, and then us. Many of these universes spawning from different conditions would be grossly inhospitable. Universes that had only antimatter or equal antimatter and matter. Universes that lasted a microsecond and are gone again. Universes where there's no causality. Every imaginable universe could be there. And so our universe is perhaps one of the few hospitable ones to life in the multiverse concept. So the final piece of audience participation, I've talked about the past, and now I want to ask about the future. So your last question is, and you get to choose, so this is not just audience participation, this is, you get to tell me how I should finish the talk. So if you could choose the fate of the universe, I'll give you the options that physics provides. The universe could end as a heat death, so everything crunches down, matter is obliterated. Not very good news for us. We won't be here, but somebody will be here. There's dissipation and decay where it sort of coasts to a halt and entropy takes over and matter falls apart and you end up with a sea of low-energy photons, neutrinos, and antineutrinos. Yeah, doesn't sound very good. There's cold death, which is the big rip where everything sort of dissipates and is stretched out in a kind of dissipative cold expansion. And then, of course, there's a possibility, there is a possibility that it doesn't end and it would go on forever. And so you can tell me what you prefer. 1, 2, 3. Heave them up there. So, oh, you want it to go on forever. That's very selfish of you. I mean, I don't like to be a downer, but you're all going to be dead. It doesn't really matter. But I don't want to be a downer. I'm not going to finish by being a downer. So here I will just summarize the kind of nasty scenarios. And because you want the universe to go on forever, okay, fine, have it your way. I will tell you the scenario that cosmologists have come up based on these multidimensional theories of space-time. So cutting edge, bleeding edge, you may not be right, but it's very comforting, of course. And these theories not only have an eternal universe, but they posit that the Big Bang was not the origination of everything, that the Big Bang was an event in a series of events taking place in higher dimensions. So they finesse not only the issue of ending, but the issue of beginning itself. It's an eternal universe. And it works a little bit like this. You have to imagine higher dimension, they're reduced into dimensions I can show on a graph. You imagine higher dimensional membranes, or brains as they're called in the jargon. So these are higher dimensional spaces, maybe 5, 6, 7 dimensions, within which our 3 dimensions of space and 1 of time are embedded. And our universe, our expanding universe, is spawned by the collision between 2 higher dimension brains. So the energy of that collision is what generates the motive force for the Big Bang. Subsequently, forces operating in those higher dimensions pull the brains back together. The universe expands, dissipates, but then the whole cycle repeats, and the time scale in the theory is about 1 trillion years. So you have an eternal universe spawning 3-dimensional expanding universes filled with matter and radiation, caused by episodes that occur in higher dimensions and collisions of brains, or even higher dimension things that are impossible to visualize. All of this around us, the 100 billion galaxies, the diversity of structure, the stars, the planets, the people that we haven't yet met, all of this from an iota of space-time. It's kind of amazing. And not to pretend that there aren't some really profound mysteries, and you'll hear more about those next week, but I think every now and then you step out of your world and your life and the things you read every day, and you feel good because this cosmology, this idea, these ideas that are tested in part of the edifice of science, part of what we know about nature, and in a sense about ourselves, because we're part of this story, is one of our greatest triumphs. And that is the end.